Hello everyone, and welcome to part 2 of Recommender Systems with Python. In part 2, we're actually going to build our recommendation system for the movie data. Let's go ahead and get started by jumping back to the Jupyter Notebook. Alright, here I am back at the Jupyter Notebook. Now what we're going to go ahead and do is create a matrix that has the user IDs on one axis and the movie titles on another axis. Each cell will then consist of the rating the user gave to that movie. If you remember back to the previous lecture, DF was our original data frame with the user ID, the item ID, the rating, the timestamp, and then the title. We're not actually concerned with the timestamp, we're just concerned with the title of the movie, the user ID, and the rating of the movie. What we're going to go ahead and do is use pivot table to get this into matrix form. I'm going to go ahead and say moviemat is equal to df dot pivot table, and I will set my index equal to user ID. I'll set my columns equal to title, and then I'll set my values equal to rating. Let's go ahead and check out moviemat now, just ahead of it. And if we take a look at this matrix, you'll notice that you have a lot of missing values. And that actually makes sense because most people have not seen most of the movies. What we can go ahead and do is check out some of the most rated movies again by saying ratings.sort underscore values num of ratings, and I'm going to go ahead and say ascending equals false dot head of 10. Now, looking back at this, what we're going to go ahead and do is choose two movies. We'll choose Star Wars, this science fiction movie, and Liar Liar, which is an old comedy. What we're going to go ahead and do is grab the user ratings for those two movies. So I'm going to make a variable called Star Wars underscore user underscore ratings, and that will be equal to my movie matrix at star, we can keep typing here, Wars 1977. And you can use tab to help you autocomplete that. And I'm also going to do liar liar underscore user underscore ratings is equal to moviemat, and in this case it's going to be liar liar. And I can do tab to autocomplete that as well. Now just checking one of these out, for instance Star Wars user ratings, the head of it, I now have basically a series with the user ID and the actual rating they gave that movie, or null if they did not rate that movie. What we can do is use core with as a method to get the correlations between two pandas series. It's really similar to .corr, the regular correlation method, but let me go ahead and show you how we can use core with. I can go ahead and say moviemat dot, and if you remember we had core, but there's another method core with. And core with will compute the pairwise correlation between rows or columns of two data frame objects, instead of just the index or columns of a data frame. So I can say moviemat.core with, and I can pass in Star Wars, tab for autocompletion there, user ratings. And if I just take a look at this, I essentially get a bunch of titles of movies and their correlation with the Star Wars user ratings, which remember was just the actual user and then the relation or the rating they gave that movie. So I'm going to go ahead and call this similar underscore to underscore Star Wars. Because all I'm asking here is for the correlation of every other movie to that specific user behavior on the Star Wars movie. So I can say similar to Star Wars is equal to the movie matrix, which remember was this, where the user ID was essentially just a row of all the ratings they gave to all the movies they watched, or null if they hadn't seen that. And then I went ahead and said, well, how correlated is that with essentially this specific Star Wars row here? And I'm going to do the same thing for liar liar. So similar to liar liar, it's equal to moviemat dot core with liar liar underscore user underscore ratings. And don't worry if you get this warning. It's just a pandas issue, but everything should still work. It's not an actual error. It's just a warning. What we're going to go ahead and do is clean this by removing the null values and then using a data frame instead of a series, just so it looks a little nicer. We'll go ahead and just start with Star Wars. So I'm going to say core underscore Star Wars is equal to pd.dataframe. And I'm going to pass in the similar to Star Wars, and I will set my columns equal to correlation. And then I'm going to say car or core Star Wars drop NA. And I will say in place is equal to true. Run those two lines and then actually check out the data frame. And this will probably be more clear as far as to what we actually just created. Okay, so we just created a data frame where the index is the title of the movie and we have this correlation column. And this correlation column tells us how correlated this movie's user ratings were to the user ratings of the Star Wars movie. So if we sort the data frame by correlation, what we should be able to do is get the most similar movies. However, you should note that we get some results that don't really make sense. Let me go ahead and show you what I mean by that. If I go ahead and say CORR or core underscore Star Wars dot sort values, and I'm going to sort it by correlation with ascending, with ascending equal to false. And I'm just going to take the first 10. Notice that we get a bunch of titles with perfect correlation. So according to our model right now, Hollow Reed, Beans of Egypt, Maine the, whatever that movie is, Old Lady Who Walked the Sea, all these kind of weird movies that you probably never heard of before are perfectly correlated with Star Wars. Now the reason that doesn't make sense is because most likely these movies happen to have been seen only by one other person who also happened to rate Star Wars 5 stars. What we can do is go ahead and fix this by filtering out movies that have less than a certain number of reviews. So we can set a threshold for the number of ratings necessary in order to be put into our model. What we can go ahead and do is just go back to our histogram on the number of ratings. Now it looks like we get a serious decline after 100. So you can go ahead and kind of play around with the number we can do, but I'm going to go ahead and filter out by movies that have less than 100 reviews. But I encourage you later on, once we finish this project, to play around with the actual filter you're going to use. I will say core underscore Star Wars is equal to core underscore Star Wars, and I'm going to join it with ratings num of ratings. So basically what I just did was I just joined this data frame together. So with the title, I can use number of ratings there with the correlation. And remember, if you go back to the merge, joining, concatenating lecture, the reason I use join here instead of merge is because I have the title as the index of my data frame, which makes it a good fit for this join method. Alright, so what we're going to do now is filter out any movies that don't have at least 100 ratings. So I'll say core underscore Star Wars, where core underscore Star Wars num of ratings column is greater than 100. And then I will say sort underscore values, correlation, and basically the same thing I did last time. We'll say ascending is equal to false, and I go ahead and just check the head of that. Let's run that. Okay, and now we can see some movies that start to make a lot more sense. We see Star Wars and then another Star Wars movie, The Empire Strikes Back. And it makes sense that The Empire Strikes Back is going to be the most correlated movie to Star Wars. Then we also have Return of the Jedi, which is another Star Wars movie, and it's also pretty highly correlated with Star Wars. Then you have Raiders of the Lost Ark, which if you saw Star Wars, you probably enjoyed this Indiana Jones movie. And you'll notice that there's a big drop in correlation when you start to get to Austin Powers. Now, Austin Powers is a comedy, so you may or may not like it if you liked Star Wars. But one of the reasons that it may have relatively high correlation, now 0.37 isn't that high, but you may be wondering why it's showing up here. The reason is most likely it's a very popular movie, and so is Star Wars. A lot of times with these recommendation systems, really popular movies or really popular items tend to be recommended to other people who also liked another really popular item. Let's go ahead and explore Liar Liar to see if we get some different results. We'll go ahead and say core Liar Liar is equal to PD data frame. What we're going to go ahead and do is kind of review the steps we did. So remember, we grabbed the similar to Liar Liar, set the columns equal to correlation. So that very first step essentially just created a nice looking data frame for us, where we had the title in the index and then the correlation with the movie. And in this case, our movie is Liar Liar. Notice that we have a lot of null values, which are kind of useless to us here as far as recommending stuff. So we'll go ahead and say drop those, and we'll say in place equals true. So we went ahead and dropped those, and our next step is to actually get the number of ratings, and we can do that with join. We'll say core underscore liar liar equals core underscore liar liar, and I'm going to join it with the ratings num of ratings column. And now if I check out what I have the title on the index, the correlation with Liar Liar, and the number of ratings. What we're going to go ahead and do is then filter this out, by a certain number of ratings, and I encourage you to kind of play around with this value. In this case, we'll just kind of arbitrarily choose 100 ratings. So I'll say number of ratings greater than 100, and I'm going to sort values, correlation, correlation ascending equals false, and then I just want the head of that. Okay, and now we have the movie suggested to us if we really like Liar Liar. Now obviously Liar Liar has a perfect correlation. The next one is Batman Forever, which might be okay of a choice. The Mask, that's actually probably a really good choice because Liar Liar is a comedy in the 90s that stars Jim Carrey, and The Mask is another comedy in the 90s that stars Jim Carrey. But notice that as we start to drop off in number of ratings, our correlations are pretty low to begin with. They're all lower than 0.5. What you can go ahead and do is play around with this number of ratings threshold in order to see if you can get better recommendations, or maybe you can filter out some recommendations that don't really make sense. Okay, I hope you enjoyed this project. Again, you can check out the Advanced Recommendation Systems lecture if you want to see more advanced methods of creating a recommendation system based off of collaborative filtering. But in case you ever want to quickly create a recommendation system, you can do it kind of easily with pandas by just using pandas capabilities with core or with the core with. Alright, thanks everyone, and I'll see you at the next lecture.